Hello everyone, and welcome to the NewScale Robotics presentation on how to improve assembly yield and quality with automated inspection. My name is Friedrich from NewScale Robotics. I'm the marketing manager. I'm based out of our Victor, New York facility, and I've spent the past 5 years working for NewScale Technologies to deliver high precision motion systems to industrial and OEM manufacturers throughout the world. I've supported the sales and marketing at NewScale Robotics since we launched in 2018, and I work closely with manufacturers and distributors to identify part handling and inspection automation applications, bringing together the partners and technologies that are needed to solve our customers' automation requirements. Today we will review some typical applications with collaborative robots and how the use of cobots in quality inspection can be applied to both traditional applications for part fabrication, as well as some non-traditional applications to automate the use of your company's existing quality technology within the metrology lab or maybe on the production floor. I have a bunch of different application examples and videos that we'll review throughout the presentation. We'll also discuss some key industry trends within the manufacturing space that are driving customers towards automated inspection. If you have any questions, please add them to the chat and we'll address them throughout the presentation. We can also have an offline conversation if you want to discuss a topic or application in more detail. I'll have my contact information listed at the end of the presentation, or feel free to stop by our Cobot Expo booth, and I'd be happy to chat with you live. So many manufacturers tend to lump quality control, which is a really critical business function, into overhead costs, and it's not often considered a starting point for automation, even though QC is full of these expensive, labor-intensive, manual, boring, and repetitive tasks that are really great candidates for automation. Inspectors, and especially CMM programmers, are often paid much higher than many other production staff on most quality teams. And while manual tools are great for quickly checking dimensions in reference to a drawing, using them for hours on end is prone to error, could even have repetitive stress injuries, and definitely turnover because employees just don't want to sit at a bench doing this all day long. So our goal was really to enable QC automation at roughly the same speed as a human operator, take up the same amount of space that a person would need to manually inspect at a bench, and eliminate data collection errors. This also helps free skilled operators to do more productive QC tasks, like more intricate and complicated inspections, maybe something like programming a CMM, or a visual-based inspection system that you might have in the metrology lab. The QSpan workstation is what you'll see throughout this presentation. It uses grippers that function as robotic calipers to allow you to not just pick and place parts, but you can pick, measure, record, and place parts, allowing you to automate the type of repetitive inspection processes that we're showing in this video on screen. During assembly processes, operators need high-quality in-spec parts to ensure that assembled parts meet mechanical fit and performance requirements. Out-of-spec parts can negatively impact your tolerance stack-up and, in turn, your assembly yields. So automating inspection and part sorting with the robot before assembly begins allows your operators to work with binned parts with known dimensions to improve assembly yield and quality, and we'll talk about that a bit more later on. The gripper's repeatability is about 2 times better than most digital calipers, and we're removing the human variation that you see from multiple operators measuring parts manually with those handheld tools. Every production process needs to have some sort of quality process in place as well, because if you can't measure your process, you can't improve it, which is why the QC department is so necessary. And traditionally, when we're inspecting and collecting dimensional data on parts, you really have 2 primary methods that you see in most production facilities. So method 1 is the parts are measured on the floor by an operator or inspector with manual tools. And this data can be recorded manually or recorded with a direct connection to your SPC software. It's a really good way to check critical dimensions to verify that the process is producing in-spec parts, but having to use a tool for hours on end is, again, prone to error and perhaps high turnover. Every operator measures the part somewhat differently with manual tools, and that's why you use multiple operators during a gauge R&R study. They might apply different levels of force with their hand while they're using the manual tool. They may grip the part in a different location or at a different angle than another operator, or they might just record the data wrong. They might have rounded incorrectly, they may have bad handwriting, or they might have just been distracted or tired. So throughout a production day, operators are often asked to sample parts from a process, something that can often be overlooked or forgotten, or maybe even skipped entirely, as operators are required to adapt to the new challenges or tasks on the production floor. These inaccurate measurements for manual tools or forgetful operators who may accidentally allow the machine to run for prolonged periods of time without making these process adjustments can lead to failing batches of junk parts that need to be reworked or scrapped entirely, both of which are really unnecessary production expenses. Or you have the situation where you end up with some good parts that are rejected, some bad parts that ship to the customer, or insufficient data is captured to enable that continuous process improvement that you're really expecting from your quality department. Inspected features are also often limited by the basic tools allocated to the production floor. Some advanced shop floor inspection equipment is starting to become more popular, but many manufacturers still rely heavily on their metrology labs for more of those complicated geometric tolerances that you can really only get with more advanced equipment. So a typical inspection method 2 would be parts are brought into your metrology lab and they're carefully measured on more advanced inspection equipment like the CMM pictured on the right, or maybe you use a vision system or optical comparator. This is a good way to measure geometrical tolerances using more advanced equipment that really far exceeds the basic dimensional tolerances that are often recorded on the production floor itself. This type of inspection work usually involves loading parts in and out of pre-programmed inspection cycles on these machines, which is often a boring, time-consuming, and expensive operation, falling nicely into the dull category and really making it an ideal candidate for automation. These routine inspections are often performed by highly trained and well-paid inspection technicians that have really considerable training time on these more advanced inspection tools and whose time is really not best spent just loading parts in and out of a machine all day, especially in an environment where manufacturers are facing a labor crisis with many open positions for skilled manufacturing staff, including quality inspectors. Let's take a look at some real-world application examples and why QC automation is growing in importance within the marketplace. Companies like NewScale Robotics are developing technologies that can be used to automate inline inspection, like our gripper caliper. Operators would be expected to periodically check measured dimensions to verify that the parts are being produced within tolerance. So why shouldn't your cobot have this requirement as well? Inspection is one of the most critical tasks to automate if your goal is to have a fully automated cell, especially one that can run lights out and continuously produce good parts without an operator having to tend to the QC functions of that machine. Periodically inspecting the dimensions on parts to verify that they're being produced within tolerance helps machinists determine whether the process is performing correctly. This dimensional inspection data can really reliably provide insights into different process changes, and for example, this can indicate whether or not tooling on a machine has begun to wear based on the measured dimension. So this will require the operator to stop the process temporarily to adjust an offset, or perhaps even swap out a machine tool. I speak with a lot of manufacturers that have implemented robots for machine tending, but find that they keep producing these runs of junk parts because they haven't quite solved the QC piece of their automated fabrication. Adding QC automation to any standard machine tending operation can really help you better understand and also prolong the life of your machine tools, while also allowing for preventative maintenance. So robotic calipers really tend to exceed the repeatability of human operators, allowing you to also collect better data and make more informed process adjustments. Once you understand the correlation between a part tolerance's drift and the wear on a machine tool, it might also even be possible to automate those offset adjustments on your machine and enable completely lights out automation. This is a demo created by a UR distribution partner, ADI, where the precision gripper calipers on a UR5E pick and place parts out of this Herco machine and place them onto an output fixture. So the critical dimension here, the outside diameter, is inspected to determine if the part is within tolerance. So here we swapped in a 3D printed part that you just saw. It's the same exact size as that part, but it was outside of the tolerance window, so the robot made the decision in process to move the part to the fail location, in this case, into his hand. This is an example of one way to use cobots for QC automation. In a production setting, the cobot could be configured to also notify an operator when a part fails and require them to inspect or perhaps service the machine before they restart it. In something like an injection molding setting, the same type of process can occur on molded parts to inspect some critical dimensions and help us ensure that our molds are still producing good parts. In some operations where several different parts need to be assembled into a subassembly, tolerance stackups can quickly become a big problem for your yield as you try to meet your mechanical fit and performance requirements. Some assembly processes will even incorporate in-process modifications like shimming or grinding to help improve yields with the parts the operators are given. This is sometimes also called a fitted assembly operation. So this is not just a difficult process to control, but it also requires some very skilled technicians to effectively execute and achieve your yield targets. So one way to mitigate this is by inspecting parts and placing similarly sized parts into bins. This provides operators with parts that have known dimensions within a certain tolerance window, giving them a smaller sample of parts to work with before they even start assembling. So the end result is that you can improve yields by reducing the need to rework parts that don't quite fit during an assembly process. So this video here shows a very simple example of our QSpan system making real-time decisions, simply sorting and placing these balls into different channels based on the measured differences in the part. And those measurements are happening from the gripper caliper itself. Manufacturers can incorporate this type of part inspection and binning into the beginning of their assembly process to give their assembly technicians in-spec and pre-sorted parts so they can spend less time on inspection, sorting, and rework, and spend more time on assembly. In many cases, this type of inspection automation can be much less complicated actually than automating the actual assembly process itself. So you're really leaving the more intricate and complicated task to the human and the simpler task to the robot. In this application, our customer OptiPro systems used a UR3E cobot with a precision gripper caliper to inspect the dimensions on a large stack of cored lens blanks. This production involves large stacks of laminated glass that are bored out, producing several batches of these lens cores at one time. And that requires that an input tray is loaded into the cobot workstation, which is different than the single part feed we saw in some of the previous slides. Using a tray allows you to load your tray, hit play, and then walk away from the inspection system, which can really free your operators to do other tasks during the inspection cycle after a very simple input. The cobot can place these parts into fail bins or trays and will generate automatic inspection reports that can be used to improve your process on the next run, helping you improve yields, reduce scrap, and eliminate the need to have your staff stand there and inspect all those parts. During the optical fabrication process, regular quality control checks are required to ensure that parts are being cut and ground within tolerance. And this can occur at early stages of the fabrication process, such as the production of these lens cores, or later in the process as those blanks are cut, ground, and polished into precision optics, some of which will end up going into lens assemblies. This can also be true for many precision metal part fabricators as well. The flexibility of collaborative robots allows you to load many different part types onto one workstation and inspect high mixes of parts. And once an initial inspection program is set up with a cobot, redeployment for other tasks really only takes minutes. And this can empower your staff to automate any routine inspection process on your floor and handle many different batches of parts within one production shift. Many manufacturers that we speak with are dedicating more inspection work to their quality labs to meet the industry's growing demand for stricter QC requirements and more data. And this can often lead to bottlenecks within their QC labs that are really unnecessary and expensive. There's really a big opportunity cost for dedicating your valuable inspection equipment to high volume routine inspections, which can back up your entire production line. So this is an example on screen of what I would classify as a non-traditional collaborative robot application. No parts are actually being fabricated by the machine that we're working with here, but you still gain the value of freeing your CMM programmer from having to babysit this machine and load parts in and out all day long. It's a really expensive operation for a skilled technician that's often paid anywhere from $25 to $30 per hour. And the cost for implementing this type of application is really comparable to the annual total costs of 1 to 2 full-time CMM programmers. There's an application preview on screen, and the full video is on our website if anyone is interested in learning more about this case study. In this application, our customer, in this case OptiPro Systems, they actually redeployed our Q-span gripper caliper to measure and perform a pre-check on the width and the OD of some of these precision optics before the lenses were actually loaded into the CMM. So in this case, the measured dimension on the part actually triggers a specific CMM inspection program for that part based on the measured dimension that we identified before loading. So for example, if we picked up a part and identified the dimension as 10 millimeters, we would know that we have part A, triggering program A to initiate on the CMM after the part is loaded. And then if we picked a lens that had a dimension of, let's say, 10.5 millimeters, we would know that we have part B, triggering program B to run on the CMM after the part is loaded into the fixture. You also get the added benefits of using inspection application kits for this type of process, where we can pre-inspect parts to provide a lot of cost savings and really maximize the uptime of your CMM if it's acceptable to pre-fail bad parts and add in decision making to exclude them from your CMM inspection program. So for example, if in an inspection application it takes 5 minutes to inspect one part with a CMM, we could pre-inspect some critical dimensions on the next part that's on deck while the CMM is running on another part. And if we determine that a critical dimension is failing, such as a diameter or the part thickness, we can pre-fail that part and actually never place it into the CMM, saving us 5 minutes and allowing for other parts to be inspected instead. So here's another non-traditional collaborative robot QC inspection application. This video shows how a cobot can automate air gauge measurements. Air gauges are extremely accurate and reliable technology for making fast part measurements with micro-inch precision. Many of you that support industries like aerospace, automotive, or medical customers are likely familiar with this type of technology and its high-end capabilities. They generally require part loading with very tight clearances, and this video demonstrates how an older type of technology like air gauges can really benefit from the automation capabilities of collaborative robots. This application demonstrates how the Q-span gripper caliper can work in tandem with other machines to automate part picking and placement with inspection to meet your extreme high precision inspection requirements. New technologies also offer the ability to communicate with air gauges to extract all of the measurement values and catalog them for analysis by our QC team, allowing for better traceability and accuracy of your data collection. So why is all this important, and how does it relate to industry trends that we're seeing in manufacturing? So we'll talk about a few trends here and current challenges in manufacturing. Most of these challenges and trends in the industry are really interrelated, and I think they're all important to think about. So the first trend is the labor crisis and the lack of available labor in manufacturing. And I'm sure many of you have experienced the impact from the labor crisis and the challenges associated with attracting and retaining that staff, which for many manufacturers has really been compounded by the COVID pandemic. Many manufacturers actually cite this as their #1 business priority as they move forward over the next several years. And there's a lot of data on these trends, and with an aging workforce, manufacturers are really losing a large knowledge base as skilled employees with 40 plus years of experience are retiring faster than new employees are entering the workforce. So as I mentioned earlier, we found that QC is not often considered a starting point for automation, even though it's full of these repetitive tasks that are really great candidates for it. Labor is often the biggest overhead cost in a quality department, and why is that? It's really because quality is a critical function within an organization, and you need those skilled and highly trained operators to help you do the job well. And most QC processes are also manual, which further lead to those high overhead costs. In quality departments, CMM and other skilled QC programmers are often in short supply for many quality departments and metrology labs. So a lot of manufacturers hope to automate functions of their job to really maximize their time programming and optimizing inspection processes. And on the production floor, manual inspectors are often hard to come by, and/or they're hard to retain for the often dull and repetitive tasks of measuring these baskets or boxes of parts day in and day out. I speak with many manufacturers that really actually solely justify their investment in automation because they need to reduce turnover in their quality department by automating their worst QC tasks that are the most boring and tedious. The second industry trend that I'm seeing is the desire to collect more data. There's really a huge demand in the manufacturing industry to collect data in every aspect of a production process, especially quality control. More data lets you make better decisions and also improve your production processes. However, in spite of that trend, a recent article I read in Quality Magazine cited that Infinity QS spoke with 260 manufacturers about data collection, and they found that 75% of those surveyed are actually still collecting data manually, and 47% still rely on pencil and paper, which I thought was pretty unbelievable considering the levels of buzz around Industry 4.0 and data collection these days. Data and data integrity is also very important, especially in regulated industries. So using robotics to help you automatically record and store this data should help you improve the accuracy of data collection, reduce the likelihood of falsified data, and also help you avoid non-conforming inspection ratings. We're seeing many manufacturers recognize the benefits of digitalizing their data and are searching for solutions to interface all of their measurement data for analysis within a single software program whenever that's possible. The third trend that I see frequently is the desire for easier to use automation and quality control technologies. While automation is seen as a way to fulfill the skilled labor gap, it's also seen as a way to attract and retain workers. Employees really want to feel that their employers are on the cutting edge of technology and using that technology to their advantage. And it really shows employees and their customers that their company is working to improve its business with new technology and is really strategically positioned to succeed in the market with those technologies and with that staff. There's also a strong desire towards the integration of safe for human technologies like cobots, autonomous mobile robots, and smart conveyors in our factories that will keep workers safe and nowadays also socially distanced. We're seeing a lot of bottlenecks identified in quality departments, especially in metrology labs, and most companies, particularly those with limited automation experience, really want to see what we call the application of automation, as well as inspection systems, really meaning that these technologies need to be easier to use, easier to learn, teach, and adapt, really just like the apps on our smartphones. Universal Robots and strategic partners like NewScale have worked on really the cutting edge of easy-to-use automation to empower companies to use these robots and these automation systems as tools that their staff can use to automate quickly and strategically for a lot of different types of applications. So in summary, how can adding QC automation benefit your business? So we can help reduce unnecessary labor on routine inspections to lower your manufactured costs per item and also lower total costs. So operators can spend more time on assembly and less time on inspection. We can also help create more flexible and scalable operations to help improve profitability and also prepare for production changes. We can improve process control to not just improve yields and reduce scrap, but also increase traceability to help you better meet compliance. And we can also increase engagement with your employees to move them to more productive and complicated tasks that are really better suited for people, while also enabling lights out production. And finally, we can improve gauge repeatability and reproducibility of your inspection processes by removing that operator variability and putting in tools that are more precise than the manual calipers that you're using currently. So NewScale Robotics is a division of NewScale Technologies. We have over 18 years of experience and numerous patents in micromotor and motion control systems development. NewScale Robotics leverages that motion control expertise to design and manufacture reliable, high-precision end-of-arm tooling and application kits for enabling automated dimensional inspection with collaborative robots. We're really experts at merging metrology with cobots, and we're actually the only UR Plus partner that has a UR Plus certified application kit for quality inspection. We are also a certified systems integrator for Universal Robots, and that allows us to directly support customers for their robotics and metrology needs. If you'd like to learn more about our company, I encourage you to please visit our booth at the Cobot Expo, or you can stop by our website at newscalerobotics.com. So I'll now be answering some questions in the chat on the right side of the screen. And if you have any additional questions that you want to discuss outside of the Q&A, again, please visit our booth or feel free to contact me directly. My full contact information is on screen. I want to thank you all for attending my keynote presentation, and a special thank you to Universal Robots for hosting this event and inviting NewScale Robotics again to present and share our knowledge about automating quality inspection with collaborative robots. Take care.